Now we'll see in unit 2. So if you look at the unit 2, control systems for robotic joint controllers and control system, what are the different type of controllers, PD, PA and PID controllers, and the control system analysis, transition, response, steady state and other things, and feedback devices, encoder, resolver, LVDT, motion interpolation and active control, adaptive controller also. Then sensor, what are the different type of sensor we are going to see it. The robot, characteristics of sensing devices, selection and need of sensors, and robot vision sensor, and new development in sensor, what are the latest MEMS and other things, okay, and smart sensor and intelligent sensor also we are going to see it. So major component of a system. So one, if you look at the any robotic system, a robot, it should be written as in a mathematical format. So any robot will have a input, so that is called input system, and whatever the input which we are giving it, it has to be processed through the controller. Once it is processed through the controller, and it has to activate the device. So that is the second one. And third one, the plant, the mechanism process being controlled. How we are controlling the mechanism. Then what is the output? Controlled variable. How we are controlling the output. Then feedback. So once we are giving the feedback, feedback is collected by a sensor, so that it will be correcting the input signals. Okay. So it can be done with the input signal. So the mathematical models are represented by the real world system or spring mass system. If you look at it, this is the Ks, the spring stiffness, and then the spring constant. Okay, spring stiffness or spring constant, and X is the displacement due to the application of the force. And if you look at the one here, we are having a damping coefficient. Here we are having a damping coefficient, and X is the movement where we want to final one. So X is the displacement of the end of the spring, and K is the spring constant, and M is the mass of the block, and we are having one damping factor. So this is the model which we are going to write it as a mathematical equation for it. So if you look at here, so the same thing is repeated here to understand. So if you look at here, force equal to mass into acceleration. So the force due to acceleration of gravity is equal to, we know that mass is represented by m, and acceleration is represented by d square y by dt square. Dt square is a time constant. So y is the displacement of the mass. So mass into acceleration. This is mass into acceleration. The force due to dash part. The force due to this dash part equal to damping coefficient into velocity. Damping coefficient into velocity. So the force due to dash part equal to damping coefficient, which is given, the symbol is Kd. Kd into velocity is represented as dy by dt. Acceleration is double derivative of the displacement, that is d square y by dt square, and velocity is dy by dt. So force due to spring constant equal to ksy. This is the final one, ksy minus ks into x, and summing of all the force we got it. M, this is the first one, force due to acceleration m into dy square dt square, then kd by dt y1, that is a force due to dash part, and force due to spring constant. So this is the model. Then if you are taking the left hand side here, now we are going to say what is called transfer function. So this notations, if you look at here, d square by dt square, dy by dt and y. So we are going to write about this function in a transfer function. So with the S term, okay, transfer function, it is the using with the Laplace transformation. This same function is going to return it. So return as a s square of y of s is nothing but d square by dt square, and dy by dt is a s of y of s, and y equal to y of s. So now the s is replaced by the dy by dt is replaced by y of s. So we are writing in the same term in terms of a Laplace transformation. Now y of s divided by x of s, if you are dividing it, what is the final one? This is the term which we are getting as a final one as here, which is, and now we'll see a block diagram, the common block diagram. So you will have in each block diagram you will have a functional block. So this is the functional block, and you will have a signal arrow. So the signal arrow is nothing but from one place to another place, from connecting a one component to another component, how it is connected, that is called signal arrow. And summing junction, so how the signal arrows are summed up. Okay, so if you look at it, it is a plus and plus, so they are towards the one, it is a plus, so both signals are summing up and we are getting an output. And takeoff point, so from the arrowhead, if you want to take off, the just like a parallel, that's a tapping one. Okay, tapping the ones, take off. So this is the takeoff of point. So this summing up functional block represent one of the component and the constant of the transfer function. So each one, and the signal arrow indicates the direction of signal variables in the diagram and are used to connect the function block and other system components. Summing junctions, also called summing points, permit two or more signals to be added, and takeoff point permit the signals variable shared among the signal component. By conventional block diagram usually read left to right. So how to read? How to read is from left to right we should read it. Okay, with inputs from the incoming from the left. So normally we have to put the input unit in the left hand side, the output unit should be in the right hand side. Okay, that is the conventional way it is followed. So now if you look at here, the block in series, so this is the one function and y is the another function. These two are connected in a series one. So the sum up activity, so to reduce the, we are going to reduce a reduction activity. So if you are putting a so many components, finally it will have a very big circuit, so that we can reduce it, we can put it in a simplified form. So if the components are having a x and y, the summing up should be x into y. So that is in a serial one. And if you are having a two components, say x and y in a parallel one, and here we are having a summing unit, so plus and plus, so these units are given by x plus y. So now we can see it. So this is in the parallel one and this is in a serial one. Now elimination of feedback loop. So this is the elimination. Suppose if you want to put it here, so this component, how to eliminate? So this is the plus. So now this is the coming as a from summing point, you are getting a x, and this output, okay, it is giving us a y, signal y, then it is given as a -1. So if it is looking like that, that symbol is x by 1 plus xy. So you will be getting an output here as x plus 1 plus xy. Now we can see that here shifting the block. So shifting the block is this x, we want to shift it to here. So this x, we want to shift it to here. So that one it is given as, so here 1 by x. So we are giving the input one. This signal also we are giving as a x is 1 by x. So this is giving shifting as equal to x. So this circuit it is giving a shifting the function. Sometimes we will be shifting it also. So this is the conversion way we have to do it. And shifting takeoff point. Suppose this one we want to take off to the here. Okay. So that one we to see, if you look at here, this is the one and this is the one. So 1 by x we have to give it, and if you are rearranging it, that is the shifting takeoff point. And basic connection for the block. So the whatever it is given the previous one, it is a series connection. So we are giving a x as a input and we are getting a zx and y of s. So this output is given as a z of s. After processing a g1 to 2 of s, we are getting the y of s. Okay, the tutorial which I take the presentation, it is given here. So the combination will get, suppose y of s is nothing but G2 of s into z of x. So you will be getting the output as y of s, where z of s is nothing but, this output is nothing but x of s into g1 of s. So multiplication of these two will get a z of s. Multiplication of these two will get a y of s. So by substituting z of s as a g1 of s and x1 of s in this equation, so we are substituting here. So we will be getting a g1, see, taking the bracket out, g1 and g2 into x of s. So the y of s is nothing but, if you are putting a summation as these two signals, I will take it as a bracket 1. So compare the equation with the standard form out of y of s into g of s and g of s. So here these two are combined together and given as x of s equal to g1 of s and g2 of s. So these two are combined together. We are removing this z of s. Then we are getting a y of s. So multiplying to get the y of s, we will be multiplying with x of s into g1 of s and g2 of s. So we are getting this equation. So this is the serial connection. Now we'll look at the parallel connection. So now we are having a two blocks as a G1 of S and G2 of S. So we are getting the input signal here. It is split into two. Then here Y1 of S. The output from here, the block is Y1 of S and Y2 of S. So these two are sum up here and we are getting as a final output as a Y of S. In this combination, Y of S equal to, so we are having a two outputs. So we want to summing it up. Summing up as a y1 of s plus y2 of s, where y1 of s is equal to, we are getting a signal here. In the same signal is x of s is available here also, here also. So x of s into g1 of s. X of s into g1 of s, we are getting as a y1 of s. And for y2 of s, the x of s into g2 of s. X of s into g2 of s, we are getting y2 of s. So we are calculating the y1 of s and y2 of s. So by substituting these equation in this equation, so we are substituting here g1 of s and g2 of s. So we are substituting both equation and rearranging this equation. We will be getting a g1 of s plus g2 of s into x of s. So the final y of s will be getting as a, you say they combined with this term combined as a g of s. G of s nothing but g1 of s plus g2 of s. So this equation is reconverted as x of s, g1 of s plus g2 of x into equal to y of s. So the feedback loop. Feedback loop, if you look at here, x of s, we are having a summing action. So this is come as a e of s into g of s. Then we are getting output as y of s. That feedback loop is given as a h of leg s, then it is minus. So summing of e of s is equal to x of s. So this one is giving us a negative one. So this is a positive one is given as a x of s. Negative one it is given as a h of s into y of s. H of s into y of s. So this minus symbol is given as a negative 1. Then output y of s equal to e of s into g of s. So by substituting e of s value here, y of s equal to this equation, x of s a and h of s y of s into g of s. Rearranging the equation, y of s by x of s equal to g of s by 1 plus h of s. So this equation is rearranged into this block diagram feedback loop, rearranged into this one, x of s, g of s divided by 1 plus g of s into h of s, that is equal to y of s. So this is a negative loop, closed loop is given here. Now shifting the sum of point after the block. So here r of s, x of s, two input signals are there. So it will be summing up here r of s plus x of s, and the block diagram processing function g of s, the output is 1. So if you are summing up to here, so this block, if you look at this block, it is shifted to here. So to here, here. So r of s into g of s. So we'll be doing a multiplication g of s into r of s and x of s, this one will be getting y of s. Okay, now we'll see what it is. Summing point has two input, r of s and x of s. the output of the function it is given as the R of s and x of s. The input block s of s is given as R of s into x of s into g of s. So this, if you are multiplying it, we will be getting this one. So y of s equal to g of s. So rearranging it, g of s into R of s into g of s into x of s. So this rearranging it, so you will be getting the output block g of s into R of s, and by summing up both, so this one g of s into R of s into x of s, you will be getting y of s. Okay. And the output block diagram, y of s equal to the final one, what we will be getting is equation with g of s into R of s plus x of s. So the output block diagram, this is the input way, equation 1 g of s, and comparing the equation 3 and 4, equation 3 and 4, the one final one, if this is the final one, we will be getting the block diagram after shifting it. So the same output you will be getting in the y of s. Now take off point. So if you want to take off point from here, what is the equation? X of s equal to, it's taking out x of s, R of s you are getting out, y of s will be getting R of s into g of s. When you shift the takeoff point from the block, the output y of s will be the same, but there is a difference in the x of s value. So in order to get the same x of s value, we require one more block in the y of s. So shifting out here, we need a one more block, this one, 1 by g of s. So it is having the input value of y of s, the output value of x of s. The block diagram shown the following figure. So shifting up here. So this shifting to here, we will be getting the, if you are replacing this block, we will be getting the same output in the y of s. So shifting takeoff before the point. Okay. So x of s into y of s into g of s, and if you are replacing with the here g of s and taking here and here. So when you are shifting the taking point before the block, the output y of s will be the same, but there is a difference in the x of value. So in order to take the x of x value, we have taken one more block as g of s. We need a one more block as a, so this block from here to here, previous one from here to here. Now we are moving from the before the point. So before the point, we need a g of s block to compensate this one. Okay. And there is a block reduction rule. There are 6 rules are there. So rule number 1, check the block connected in series, simplify. First, wherever, if it is a very big diagram, we have to check where the series connection is available. Okay. Then next one, check the block in parallel and simplify. So after doing a series one, then we have to do a parallel one. Then check the block in the feedback loop and simplify. So next stage we have to do a feedback one, where the negative reverse one. Okay, feedback one, and we have to simplify it. And then rule number 4, if there is a difficulty with a takeoff point, simplify with, while simplifying, shift it towards right. So we have to do it in the right direction with the simplification. Okay, when there is a takeoff point is a difficult one, we have to do a shift in the right direction. If there is a difficulty in a summing point, while simplifying, shift towards the left direction. So now we can understand rule number 4 stating that if there is a takeoff point, it's simplifying towards the left, we have to do a right hand direction. If there is a summing point while simplifying it, then we have to do the left. Rule number 6, repeat the above step till you get the simplified point in a single block. So we want to output as a single x of s and y of s. We have to follow the rule number 1, 2, 3, 4 and 5 and 6 repeatedly, such a way that we will be getting the one input block as x of s and another input block as a y of s. So from this manner, we can control it, we can simplify it, all the diagram, all the block in a simple one, so that it can do the one. Thank you.